Hello friends, welcome back. So in this particular video lecture we are going to continue with the solution of the problem that we had started in the previous video lecture. Okay, so here three bus system was given and we had to carry out uh, two iterations with using acceleration factor, and here the given two buses are PQ buses, and they have been given in the active and reactive power values have been given in megawatt and MVR, which needs to be converted into per unit values, which we have done. And also we try to obtain the for first iteration we try to obtain the value of V2 as well as delta 2 here. Okay, so now here we are going to determine uh, same way for the third bus, and later on we are going to do the second iteration, but right now we are going to determine for the bus number 3. Okay, so here I'm going to use for voltage in bus 3, or I will write it as the voltage at bus 3 is given as, so as it is a first iteration, so it is V3 of 1 y33 because it is yii in the bracket P3 minus jq3 divided by V3 of 0 conjugate minus, so here I is 3, so 1 2 3, so 3 will be outside, therefore 1 and 2 terms will be there, V1 minus y3 2, because 3 is outside, y3 to V2. Okay, so V2 is a variable and already first iteration has been obtained, so here we will take it as V2 of 1. Okay, so updated value we need to substitute here. Okay, fine. This updated value is nothing but the accelerated value. Okay, so now substituting the parameters over here, 1 divided by minus J9, then P3 value already calculated minus 0.6, Q3 value is also minus 0.3, so minus of minus plus J0.3 divided by, and V3 of 0, so V3 of 0 is assumed value, which is 1 at an angle 0 or 1 plus 0. Okay, so 1 plus J0 or 1 at an angle 0 minus Y31 is J4, and V1 is again the given value 1.02 plus J0 or at an angle 0 minus Y32 is J5 into bracket the accelerated value of V21, which we have already obtained, substituting that value 0.992 minus J0.0499. Okay, so simplifying this, we're gonna get 1 divided by minus J9 into bracket minus 0.8495 minus J 8.74, and further simplification of this will give us 0.971 minus J 0.0943, and in polar form same thing can be written in the polar form as 0.9756 at an angle of minus 5.55 degrees. Okay, so this is the V31. Okay, so it is V31. So this is just plain iterated value, it is not accelerated yet. So now we'll try to obtain the accelerated value of this. So accelerated value can be obtained by first determining the difference of the this iteration with the previous iterated value, so which is V3 of 1 minus V3 of 0. So V3 of 1 is the same that we have already obtained at an angle of minus 5.55 minus 1 point v3 of 0 is assumed value, so 1 plus j0, or 1 plus 1 at an angle 0. So simplifying this, we're gonna get the final value of this is minus 0.029 minus j 0.0943. Therefore v31 accelerated is going to be equal to v3 of 0 plus alpha times 1.6 times del of v3 of 1. Substituting this, 1 plus j0 plus 1.6 times del of this is minus 0.029 minus j 0.943. Okay, so this is what we get, and simplifying this, we will get final value of this accelerated v3 is 0.9536 minus j times 0.1509. okay, so this is accelerated value. Okay, so the voltage at the end of first iteration is, so finally we'll write voltage at the end of first iteration is, so v1 of 1, it is a specified quantity, does not change, j0. Second, v2 of 1 0.992 minus j 0.0499. then v3 of 1 is 0.9536 minus j 0.1509. okay, so now let us calculate the second iteration. okay, so now again add bus 2 v2 of 2. okay, so now it is going to be v2 of 2 because it is the second iteration, so therefore again it is y22. okay, so p2 minus jq2 divided, here it is going to be v2 of 1. okay, because it is 1 less than the iteration that we are considering. If it is 2 here, so it is going to be 1 here, so 2 minus 1. okay, so then I is 2, so y2 k equals to 1, as it is v1 minus y23 v3. so now here it is 2, so here it is going to be 1, earlier it was 0. okay, so here these changes we need to remember. okay, so now let us substitute the parameters. so y22 is minus j8, p2 is minus 0.25, q2 is minus j.1, so minus into minus plus j.1. in the denominator v2 of 1, so v2 of 1 already we have expressed above. okay, so v2 of 1, so let us just substitute the same, 0.992 minus j.0499. okay, so minus y21, so y21 is, and here conjugate of this, minus y21 is j3 in bracket 1.02 plus j0 minus j5 into v3 of 1 is already obtained, so the same value we need to write. Okay, so this is what we get after substitution. So then simplifying this, the result will be equal to 0.9643 minus j.125. Okay, so which is V2 of 2, and this in the polar form is given as 0.9724 at an angle of minus 7.39 degrees. Okay, and this is the plane iterated value. Now we need to determine using the acceleration factor. So for that, first let us find the difference v2 of 2. So this v2 of 2 will be equals to v2 of 2 minus v2 of 1. So v2 of 2, whatever we have written here, two 5 minus v2 of 1, already we have calculated, okay. So simplifying this, we're gonna get minus 0.0277 minus j 0.0751. okay, and v2 accelerated is going to be v2 of 1 plus alpha times del of v2 of 2. v2 of 1 is 0.992 minus j 0.0499 plus 1.6, alpha value is 1.6 times minus 0.0277 minus j 0.0751. okay, so which is 0.9477 minus j 0.170. so this is v2 of 2 accelerated. Fine. In the same way, voltage at bus 3, is v3 of 2 equals to 1 divided by y33 p3 minus jq3 divided by v3. So here it is 1 2, so 2 minus 1 is 1 star minus y3 1 v1 minus y3 3. So y33 is outside, so it is y32. So v22 substituting the values, 1 divided by minus j9 times minus 0.6 plus j.3 divided by 0.9536 minus j 0.01509 minus y31 is j4, v1 is fixed value 1.0 at an angle of 0, minus y32 is j5, and v1 of 2, sorry, v2 of 2 is 0.9477 minus j.17. So simplify this. 0.93496 minus j.1573, of which can be written as 0.9481 at an angle of minus 9.55 degrees. Okay, so this is the value v3 of 2. Okay, so again we need to calculate the accelerated value. So therefore the accelerated value can be determined by first of all finding the difference. Okay, so del v32 is v32 minus v31. Okay, so v32 is same value what we have written above, and v31 is what we have obtained in the previous iteration. Okay, so which was 0.9536 minus j.1509. Okay, so now this will be equal to minus 0.01864 minus j.0064. Therefore v32 accelerated will be equal to, so v31 plus alpha times v32, no, sorry, del of v32. So therefore v31 is 9536 minus j.1509 plus 1.6 times minus 0.01864 minus 0.0064. Simplifying this, we will get 0.92377 minus j.16114. Okay, so therefore the bus voltages at the end of second iteration are v1 of 2 is going to remain same, doesn't change. v2 of 2.9477 minus j.170, and v3 of 2 is going to be 92377 minus j.16114. Okay, so this is it. So in this way we can determine the required variable values for whatever iterations asked in the examination. Okay, so we have seen with the help of first example earlier how we can obtain for first iteration without any acceleration factor, and in this example we saw when the acceleration factor is given and when we want to evaluate for higher iteration how we can use the Gauss-Seidel method to calculate the desired values of the variables. Okay, so that is it in this particular video lecture. So I'll see you in the next video lecture. Till then, happy learning and thank you.